Let's get started. All right. Is everybody able to see my screen there? I think we should be good. Thanks, Dan. Okay, so hopefully everybody's in the right space. This is the Intro to Fedora workshop. As we kick things off today, I did just want to draw everybody's attention to the Fedora Code of Conduct. Obviously, the Fedora community is a welcoming, vibrant, and diverse group of individuals, and we aim to treat everyone with respect, understanding, and compassion. So, just a note here, we operate in a community setting. We want to be courteous to all of our fellow colleagues. Everybody comes from different backgrounds and situations, and in the spirit of community, let's all just remember that to be kind to each other. Have a good time today. That is a link to the code of conduct should you need to review it or go through it. There is also a reporting system in place. Should you need to get a hold of somebody, you can feel free to use the Fedora conduct at lyrasis.org. Outreach, or there is contact information for myself, Dan Field, our program developer, as well as the director of operations for our division at Lyrasis. So lots of people, if you do need to get a hold of anybody, that's all the contact info. Okay, so let's get going then. I'm just kidding. There we are. Awesome. So just a quick little intro to Fedora. This is the current state of the community as it stands today. There's approximately what we're saying is around 300 known installations around the world. Now, I just mentioned being open source. So this comes from a little bit out of date self-report registry that we were previously maintaining. Our organizational home Lyrasis was hosting this registry for us, and we've been doing work to continually update that. But we don't know exactly where all of our users are, what versions they're on. So we just have to use the information that we have available to us. So there is a new link to our new updated registry at the bottom of the page here. I will be sharing that in the chat shortly. But we are encouraging anybody that is on a version of Fedora to go ahead and register their instance so we can get a stronger, more up-to-date, better understanding of what versions of the software exist in the wild. What we do know, though, based on interactions with the community, is that our users are very diverse, both in the types of institutions that implement the software and how they're using it. So that's one of the features of Fedora is its flexibility. We see that no two implementations are alike, but for us, this gives us a really rich complement of the types of users that we have and allows us to see that Fedora is, truly being used as it's intended. So supporting a lot of use cases. We operate with a small yet really active team of committers and technical contributors who regularly meet. They're responsible for the ongoing maintenance, upkeep, and development of the software. So they're the ones that you'll see on Slack or in the communication channels, answering your support questions. They're the ones completing tickets, fixing bugs, et cetera, et cetera. So we're super grateful for all of their efforts. There are some of them joining us today. I'm going to call out their names here in a minute, but just a big thank you to them and all the work that they put in. Over the last year or more, we as a community have really been focused on trying to create some more ways to contribute to the community that aren't maybe just development contributions. There are lots of skills and talents that we recognize within the community, and we're never going to turn down an offer of contributions. So there's lots of different ways to get involved. And then lastly, Fedora has shown a strong resurgence in its presence out in the community. So we have users going out in full force to talk about their work, share their implementation stories. We're sharing it via blog posts and things like that. But our users are going out speaking at conferences, talking about what they're doing and how they got there. And for us, that's a really strong showing, and we're really grateful for that. And so this is us. We are a small program team. So there's myself, I'm the program manager, and Dan Field, who is our other facilitator today. We're responsible for maintaining program operations and communications and essentially making sure that everything is running like a well-oiled machine. Dan handles a lot of the technical side of things, development efforts, and I'm here to kind of oversee general operations. So the program priorities and focuses are established by the Fedora Governance Group. And this is a group of elected individuals, mostly from institutions who support the program through contributions to our membership program. But we also have community representatives within this group from institutions who are not paying members. And then we also have seats and positions available for stakeholders from our other open source sister communities, we call them. And these are communities that rely on Fedora. So they're, Samvera community, Islandora community, OCFL community, And this group really aims to be as representative of our entire community as possible. We've worked really diligently, to increase representation from big and small institutions, as well as institutions from outside of North America, because we do recognize that we're a global group of users, and so our governance group should be representative of that. Much of the technical work is handled by our wonderful and active committer team, who I mentioned. I'm just going to go through them really quickly. So we have Ben Pennell from University of North Carolina at Chapel Hill. There's Jared Wicklow from the University of Manitoba. Damian Katz from Villanova University. Dorn Shalvey and Calvin Shu from the National Library of Medicine. Thomas Bernhardt from DocuTeam. James Alexander from the Open University. And then, of course, this could be you. We are always open and willing to welcome new contributors to the program in any way. And, we can talk about those ways that you can contribute in a little bit. So what is Fedora? I mean, I think everybody has a general understanding. That's why you're here today. But very simply, Fedora is an open source repository software that's used for the management and dissemination of digital content. It can be used for access and preservation purposes, as well as to provide even more specialized access to large and complex digital collections. So I mentioned our Fedora users come from a wide variety of institutional types, sizes, and geographic locations. And you could probably tell just from looking around the room here that, we're very diverse in nature. Fedora as a software can store, preserve, and provide access to any type of digital content. It can hold any file format. You can really put whatever you'd like into it. Fedora is flexible. So within Fedora, you can model your content however you'd like and build whatever relationships you need in whatever complexities you have to support your individual use case. And it does this through support for semantic relationships using linked data and RDF. And you can use those to build out different object models that are going to meet your specific needs. We do know that Fedora works at scale, so you can easily store millions of objects of varying sizes in a Fedora repository without any problem. So with Fedora 6, we are working on consolidating some more standardized performance metrics that we hope to be able to share with the community to help users and others understand what we mean when we say performance at scale. What you may have in your repository, what you may consider a large number of objects may be different for a different institution. And so it's hard to really kind of standardize those performance metrics. So that is a goal that we have and something that we're working on actively. Fedora is designed to interoperate with other applications and services, though. You won't find a Fedora by itself. A lot of folks will use it to support their digital preservation. And then access is provided by a front-end client like Islandora or Samvera or something custom. And then lastly, Fedora has a published API. So in Fedora 6, the API is mostly unchanged from version 5, which is a great benefit to anybody who was using it before Fedora 6 was released. So why use Fedora? Why would you add it to your infrastructure? What are the benefits? The first one being that flexibility. I've mentioned it a few times, but it can really support those simple or complex use cases. There are no restrictions in Fedora on your metadata or the organization of objects, so you can really do a whole lot with it. Content in Fedora is durable. So with the adoption of the Oxford Common File layout in Fedora 6, which we'll get into in a few minutes, the software is really focused on ensuring your content will exist long after the hardware is gone, that it lives on, and that's the goal. Fedora is standards based, so we use standard web conventions for interacting with the application. REST, LDP, Linked Data Platform, OCFL I mentioned, and the API. So these are all standards that we use to operate within Fedora. Fedora represents a globally installed group of users. We have known instances of Fedora in some very prestigious and, big and small institutions all around the world. And, for us, and I think a lot of others, this really validates the use of the software. People like using what other people are using, and they like using something that they know is both globally supported and long-term sustainably supported. Fedora is over 20 years old, and we have users that have been with us from the beginning all the way through. So that really kind of strong, concrete background of knowledgeable individuals working with the software is a good validation point for us. And then we really are a community supported open source program. So you saw the small program team that we have, and much of our success and our growth really is because of the support and advocacy of our community members. So we have seen a lot more engagement over the last couple months, which is really exciting for us. Adoption rates of Fedora 6 are growing every day. And so we're really thankful to that community. And I think others tend to lean in where they see that excitement and engagement happening. So that's really exciting. So in Fedora 6, which is the most current version of Fedora, that was released in 2021. Just last month, we released the most current version, I guess, if you will. So 6.5.1. And along with Fedora 6 becoming or being a more modern and robust piece of software, things that you can find in Fedora 6 are, we have some very strong, extensive migration tooling and documentation. And this was thanks to an IMLS grant that we received. So now there exist tools and step-by-step instructions on ways to migrate from Fedora 3 to Fedora 6. And we're going to go through some of those tools today. But 6.0 offers a built-in simple search, which is not something that we had available before. We also have performance monitoring capabilities through an integration piece with Grafana and Prometheus. You can look at how your repository is operating in real time, which is nice. And there's also some basic metrics collecting for anybody that's interested in seeing kind of a snapshot of what's inside your repository. I think some of the things that you can look at are, object count by MIME type, byte counts, etc. Just some, simple, quick, easy, but helpful metrics that our users have said that they are interested in. And then with 6.5.1, we updated we updated to the most current OCFL Java library, which in doing so brought performance improvements for S3 write speeds, which was something that we had noticed in previous versions was potentially lacking. So these are much improved now with the new update. We also made some configuration updates, which allow encoded slashes, which came out of a collaboration that we have within the Samvera community with the Hyrax users. So this was something that we needed, that the Hyrax users were looking for. So that update is in there. And then, there's a couple of other feature requests that came out of the community and documentation updates, etc. So I did just see there was a question in the Slack. Oh, maybe, no, it was Dan sharing again. Okay. Awesome. There we go. So I mentioned that you won't often find Fedora on its own. So this is kind of just a snapshot or short list of some other open source front-end solutions that are available that, within communities that we actively collaborate with. So Fedora is really that middleware piece of software. It's kind of below the front end of a discovery system, like something you might find in Islandora or Samvera, and above storage. But this design is intentional because, not all users want the same thing or need the same things for their access. So if you were unaware, Samvera is a Ruby-based application and Islandora is Drupal-focused. And then there's also Fedora, which is an open source full stack repository solution that's based on Fedora 6. So Fedora and its community is managed out of the University of Vienna. And then, of course, there are vended solutions and custom options as well. So lots of kind of opportunities to customize your infrastructure as you need. And I'm just going to go through really quickly some examples of Fedora users that we know of. So the first up here, this is an institutional repository. So this is Arminda, which is the institutional repository at Whitman College. The team at Whitman migrated from Fedora 3 and an Islandora legacy system back as part of our IMLS grant in 2021. They were one of our pilot partners on that project, and they migrated to Fedora 6, and they have Islandora 2.0. So this is a really nice example of an early migration success story, and the team at Whitman continues to iterate on their instance as both Islandora and Samvera continue to update. So there's a link to the Arminda IR there. And this is design safe, so a very different use case. So this is a research repository from the Texas Advanced Computing Center at the University of Texas at Austin. So design safe holds high volumes of research data on natural hazard scientific research. So they are currently using Fedora 4 and a custom front end, but Fedora 4 is not meeting their curation and performance needs. And so they're very interested in the features offered by Fedora 6, specifically OCFL, and those kind of noted performance improvements that we've seen with users moving to Fedora 6. So they have a very interesting setup with their Fedora in that they use Fedora to curate and store and hold on to their very specific metadata that they have written and created for all of their scientific projects. They have a lot of different um, data types in some very different models. So some of their research projects are, deeply nested data sets that have a lot of very small files. And then there are others that have less files, but very large file sizes, think LiDAR images, things like that. And they store all the objects in their high performance computing center, and they use Fedora as a broker for the metadata and to kind of store all those relationships. DesignSafe is Core Trust Seal certified, and Maria Estiva, who is our Fedora contact at DesignSafe, was kind enough to talk about her experience in becoming Core Trust Seal certified in a blog post. That the link is there, and you can read through it after if you'd like. And then also the team at DesignSafe was involved in some preliminary performance testing of Fedora 6 in their HPC environment that we started last year. And we did present on those initial findings at Open Repositories last year. So I provided a link to that presentation if anybody was interested. And then this is Villanova University. They use Fedora 6 for content that they have digitized from their special collections, as well as the collections from some of their regional partners. So they have a program, a digital partnership program, where they support smaller institutions who may not be able to host and scan and digitize the materials. They do it through this partnership program for them. They migrated from Fedora 3 to Fedora 6 about 2 years ago, and they have approximately, and this could be an outdated figure, Damien, you can feel free to correct me, around 800,000 individual objects representing about 40 terabytes of disk space. And the team at Villanova were major contributors to the Camel Toolbox, which is a Fedora tool that supports a variety of messaging applications to use with Fedora. And they wanted a way to send HTTP messages out of Fedora into another system in response to changes in the data. So we're going to go through and talk about the Camel Toolbox later on today, but this is just one of those really nice examples of community coming in, needing something to support their Fedora use case, and being able to give back to the community. So thank you to the team there. And then the last one I just want to touch on is the public archives. So here, these are newer members to the Fedora community. This is the Archives of the Republic of Slovenia, and they're using Fedora for preserving and providing very specialized access to digitized public archives. So the Slovenian Public Archive Service, or SPAS, consists of the Archives of the Republic of Slovenia, along with 6 other regional archives from around Slovenia. So they have a mutual archival information system that consists of storage, Fedora 6, and an archive repository solution called Scope Archive. So at present, they currently have about 8 terabytes on disk, with the goal of moving all 7 public archives into their Fedora-based infrastructure soon. And once that's done, they're anticipating that's going to hold about 100 terabytes of digital reproductions of archival material, excuse me. They migrated from Fedora 3 to 6 about a year and a half ago, and SPAS is, regularly contributing or leaning into the community, and they've become active over the last year since their migration. So overall, you can see this is just a very small set of examples, but there's a lot of different use cases for Fedora, and so we could go on and on about that, but let's get into it a little bit more here. All right. So this is Fedora conceptually as it would exist in an ecosystem. The little green can represents a Fedora repository. So in the can, you've got, you can see there's binaries and RDF, or potentially some metadata where Fedora is going to hold on to the objects and store them. But if you look also, you can see that those binaries could be externally stored and simply linked to in Fedora. So Fedora is going to hold on to the connections or the relationships, but the files themselves are stored elsewhere. So this isn't an uncommon use case. We do see institutions doing this with potentially things like their masters, where they want to store them externally, whether that be on-prem or in supercomputers, whatever their use case happens to be. But they use Fedora then to just hold on to and store the metadata or the metadata relationships for those particular objects that are stored elsewhere. And then in the gray here, you'll see that these are applications that will use Fedora and can interact via the API. So you might have a website or a IIIF server to pull content from Fedora via the API and provide it to the users. And then the little Wi-Fi icon here represents Fedora's asynchronous messaging interface. So built into Fedora is this messaging system, which we're going to talk about in a bit, excuse me, but it allows applications to speak to Fedora as well as listen to and respond to lifecycle events that are occurring in Fedora. So instead of continually having to query for these new events or messages, this happens asynchronously, making it a little bit more efficient to identify when these things are happening. And then on the left there in purple, this is the Camel Toolbox, that integration point for Fedora that I was mentioning. It listens for Fedora repository state changes, maybe resource creation, updates, things like that, deletion messages. And then it's going to direct those messages to whatever, some different microservices that you would configure, like triple store indexes, Solr indexing, or your HTTP server. And this is that piece that I was mentioning before that came from the team at Villanova. And so very basically, Fedora is your repository for digital resources. Everything in Fedora is considered a web resource with an identifier, excuse me, or a uniform resource identifier, a URI. You can have two types of resources. There are binary resources or container resources. So container resources are metadata resources. They might be a little bit more descriptive in nature. And I'll just mention again, Fedora can hold and store any file type. It doesn't matter what type of file it is. It can hold on to it. Resources are described and can be expressed as RDF triples. And then from there, you can build out your hierarchy within your repository by using any combination you'd like of these binaries and containers. So we're going to look, this is what we're going to be looking at shortly here when we get to the hands-on, but this is what a resource might look like in Fedora if you're describing it using properties. So this is from the UI side of things. In production or in kind of like real world instances, you would take these properties and serve it into a user-facing front end for display and access. But this is what it's going to look like while we're working with it today in the UI. So there are two types of structures that you could potentially use in Fedora. There's hierarchical and flat. So with hierarchical arrangements, you can see that you might have something like a collection of books, which acts as a container resource, and it likely has some properties or things about it that describe it. Maybe it's the title of the collection. And then within that collection, you would have your, kind of several individual books, each with their own potentially descriptive metadata. This would be maybe author, publication information, things like that. And then this book could also be its own container, and you just kind of build it out from there. You might have pages within the books, which could also be containers and hold their associated metadata, page number, descriptions, things like that. And then you would get down to the born digital items or the scanned copies of the pages themselves, which could be added as binary files. And all the lines that you would see connecting these resources are your metadata RDF properties, connecting the resources all together into this kind of structure. So that's one way to describe it. Another way to store collections is flat structures. So you could take that same book or that same book collection in Fedora and have it exist in a flat structure, but still present the same kind of hierarchy to a user by using the RDF relationships to build out the structure. So you might have books that belong to more than one collection. You can store them wherever you want in your repository, and then just build out that hierarchy, as I was mentioning, using the relationships. So it really would just depend on your use case, and it highlights again the flexibility of Fedora, being able to store objects one way but display them to your users in different ways, and it's really based on your individualized use case. So with that, I am going to hand over to Dan, and he's going to get into some of the core features and then move into hands-on.
Okay, so Fedora has it builds on a number of existing services and standards. For providing our CRUD operations, we implement the linked data platform standard, which is a W3C standard. We use Memento for versioning, which is a standard that originated from the Internet Archive. For authorization, we use the Solid Group's Web Access Control, WebAC. Solid is a group within W3C, but it's not actually a ratified W3C standard as yet. For fixity, we support the digest and want digest HTTP headers, and we support the SHA-1, SHA-256, SHA-512, and MD5 algorithms for our fixity checking. For persistence, we sit on top of the Oxford Common File Layout, which is an open standard for persisting your files on disk, which we'll get into later on. And for our messaging service, we implement Activity Streams 2.0. So to get into a bit more in depth about the Oxford Common File Layout, because this was introduced in Fedora 6 to replace the prior storage mechanism, which wasn't particularly performant and obfuscated the data somewhat from the users. So why was OCFL created? Well, there was a requirement for a simple structured file format that was human and machine readable, that allows digital objects to outlast the systems that create and preserve them. So they can be so that's a standard format that they can be read by various systems through time. We also want to store the metadata alongside the data. And they implement the FAIR principles of findable, accessible, interoperable, and reusable. What OCFL really gives us is this human readable file structure on disk with all the metadata sitting right next to the files, where you could take the system from on top of it, throw it in the bin, build a new system from scratch that applies the OCFL standard, or buy another system from off the shelf, or implement another third-party open source system that provides OCFL, and you could stand it up on top of your existing data and have a fully operating archive on top of the original OCFL file layout that you had. So the spec and implementation notes are available on the project's GitHub repository pages. The specification describes an object at rest, along with the structure of the file system and the contents of the inventory.json file, along with some examples of usage. And the implementation notes detail best practice for implementers, as well as recommendations on how clients may interact with the file layout. Some of the benefits of OCFL. Completeness. A repository can be rebuilt purely from the files it stores. So as I said, you could knock down the existing software on top of it, build a new piece of software, or take another one and stand it up on top, and you would have another running repository. Parsability by both humans and machines. In order to be truly digitally preserved, it was important that not only could software read the underlying data, but a human, if they were to read it, to be looking at the file system, could make meaningful interactions with the data. Without actually even understanding the API or the standards themselves. Robustness against errors, corruption, accidental or deliberate, and migration between storage technologies. Versioning. Repositories can make changes to objects, but the history still persists to allow referential integrity and recoverability. Storage diversity. Content can be stored in diverse storage infrastructures, including cloud object stores. And efficiency. Many design decisions were made with a review to computational bandwidth and storage efficiency in the light of real-world experience. So this is an example of a single file in a single OCFL object on disk. On the left-hand side of the screen, you can see a sort of tree structure layout of the file system. So the object root being a directory. You've got then the namaste file, which is the 0 equals OCFL object 1.1. Just details the actual version of OCFL standard that's implemented here. You've got an inventory JSON at the top level, And then you've also got a single, you've got a SHA-2 512 of that inventory.json, just so that you can be sure that the inventory.json has not been corrupted. And then you've got a version under the v1 directory. So this internally has another inventory.json file, which contains the inventory for this version alone. There's another SHA-512 of that inventory.json file to confirm again that this is a valid file. And then the actual content lives within a subdirectory called content, where you will find the file.txt. In this case, it's a simple text file. On the right hand of the screen, what we're showing here is the inventory.json file at the top level. So you can see it's highlighted blue here. So this is for the full OCFL objects inventory.json. You can see here that internally it tells us which digest algorithm was used. The head points at the most current version. In this case, there's only one version of the object, so it's v1. But if you'd created additional versions, which we'll come across later, this would point at the most recent version. It has the full identifier, which is a URI. Then we have a manifest, a list of all of the checksums or fixed values, hash values for each of the files which are contained within. It has a type, which is an OCFL specification type of inventory. And then we have the versions. This is another JSON object list of versions. In this case, we only have the one. It's got a date time create stamp. It's got a message, which is saved with the version, and another state which contains the fixed value again for this particular version at this moment in time. It also contains a user information that can be contacted regarding this particular object. So Fedora for digital preservation. Why Fedora? Well, first of all, it stands on top of OCFL, which itself was designed with digitization at its heart. It provides a long-term human-readable standardized format for storing data along with metadata and its digests, as we've already talked about. Versions are maintained within Fedora, again, utilizing OCFL's versioning capabilities, and those are implemented throughout the Fedora API as well. We have native fixity checking from the very moment of ingest all the way through to the fixity service, which can provide you with up-to-date fixity checks on your objects. It's completely standards based. We talked about those in the first couple of slides, which standards that Fedora sits on top of. And it's open source, which ultimately gives everyone the ability to read the source code, to modify the source code, to contribute towards the source code, and hopefully that will give it a long-term future hopes as well. Okay, uh, time for the hands-on portion. Um, you've already got the URL, I think, for the hands-on portion, but I will just share this in the chat again if I can find the chat window.
I got it here if you
Oh, thank
want.
you. There we go.
While I'm sharing links in here, Dan, there was just a question from the community Q&A doc. Going back to when I was talking about hierarchies, the question was, would hierarchies like those represented in born digital collections be supported? Another way to think of this is as a file directory with subfolders and individual files.
So any combination of files and directories. A directory is basically just a container in OCFL nomenclature. Yeah, absolutely. I don't see anything that you could do in a born digital way that you couldn't implement in Fedora. They are effectively one and the same. Unless I'm misunderstanding part of the question, but yes, you could have any combination of flat or hierarchical structures with files or containers at any of the given levels.
Thank
Hopefully that
you.
answers the question.
If you have a follow-up to that, you can either feel free to unmute or just drop it back in the doc there.
Please do. And also, I think there are a couple of the tech team in the chat who may be able to answer questions before I see them as well. So,
For sure.
okay. Yeah, as Aaron says, so the plan is to take us through the hands-on portion. I'm going to try and display the slide for each section first because there's relevant information on the slides for each step. And then I will change window to a browser session and demonstrate it to you live as well for each step. So hopefully you'll be able to follow on. And if there's any issues, there's still a screenshot on the slides to follow through from. Okay, so um, CRUD, create, read, update, and delete. This is the basics of resource management in Fedora. It's a standard-based pattern for creating and managing resources, and we'll show you how this is actually achieved in Fedora. So here's a little cheat sheet about the browser interface and what you're generally going to be working from for the next few slides. You can see on the left-hand side, within the big orange curly bracket area. This is what's represented in CRUD or through HTML as through HTTP as a GET request. So if you were performing a GET request on the object, this is kind of a UI interpretation of what you receive back. Ultimately, it's the resources properties listed out for you in their sort of key value pairs. At the top of the screen, you've got the resource URI, the Universal Resource Indicator. Uh, this whole thing, including the HTTP ://localhost :8080, is all the identifier. So something to bear in mind when you are implementing Fedora is the URL that you host it at, especially if you're doing anything funky with um, reverse proxying, that sort of thing, port numbers and things that might get masked, they will actually form part of the object unless you pass some of that information through to the back-end system. So just something to be aware for implementers. On the right-hand side, then you've got a link to the slug, which is the identifier in its sort of alphanumeric and hyphen separated form. You've got the post, which is the update. So this is how you perform post operation on the API effectively. In this example, we can update properties using the update button, which would ultimately perform a post operation in the back end. Versions are how we patch an object. So using the HTTP patch verb, you create edits to an object. And finally, the HTTP delete is implemented via the delete button here. So this is just trying to tie together how the API, the CRUD parts of the API are represented in the user interface. Hopefully it'll make more sense as we get to each individual step. Okay, so first of all, we're going to create a new resource. So this is using the post functionality. If you'd like to go to your browser and go to the link that's provided in the spreadsheet, it should be to the HTTP an IP address :8080 /fc repo /rest, and that is the top level of your Fedora repository. Remember that the username and password is Fedora admin with a capital A for admin, and then in the type field on the right hand side, we're going to select basic container. It should already be selected because it's the default option. In identifier beneath that, we're going to type in the text box image dash collection or hyphen collection. And then we're going to press the blue add button at the bottom of the right-hand column. So if I switch to the browser window, I'll talk you through that now. Okay, so when I first go to the IP address :8080 fc repo rest, I am prompted for the username and password. That's Fedora admin and Fedora admin again, exactly the same. And here I am. So this is the top level of our Fedora repository. What we're going to do is we're going to come over to the create new resource column over here. We're selecting basic container, which should be the default. And then we want to put image dash collection as the identifier. We don't need to add any RDF here, and we're just going to go straight down and add the resource. Now, when we add the resource, that's posting it. What it gives us back is a GET request. So this is a GET request to get all the properties. So now you can see that we've moved down into this image collection resource. And this is the representation of the GET request. We can see that it's got a created at timestamp, who created it, a last modified timestamp, and who modified it. It doesn't have any children at present. And these are some of the properties that get created by Fedora by default. So these are RDF types that are applied. You can see that we've created a container. It's also an RDF resource, and it's also an RDF basic container. And then from the Fedora ontology, it's also a Fedora repository container and a Fedora repository resource. There aren't any other resources at this time. So we'll go back to the slides. Okay. So now we're going to create a container beneath the existing image collection container. So what we're going to do is we're going to go to the type field again on the right-hand side. We're selecting basic container again, same as last time. Then in the identifier field, we're going to select Andromeda Galaxy, or sorry, we're going to type Andromeda Galaxy with a hyphen and press the add button again. So just the same as the last time, but we're doing it underneath a pre-existing resource this time. So if I switch back to the browser, so again, we can see that we're already at the image collection level here in our identifier. So now we're going to go to basic container. Andromeda Galaxy. Spell correction has capitalized that for me, but there we go. So Andromeda Galaxy in the identifier. We're skipping RDF again, and we've added the resource. So now you can see we've got two levels of container. From the FC repo root, we have image collection, and then underneath that, we have the Andromeda Galaxy. So that's the object we are currently looking at, the resource that we're looking at. We are now in the Andromeda Galaxy. I'll head back to the slides. So, as I mentioned before, once you've pressed the post button or the add button, performing the post operation, it takes you into the object and performs a get effectively so that you can see those different parameters and properties of the object that we've just created. Now we're going to have a look at binaries. So we're going to use an image for our examples here. You should have hopefully downloaded the Andromeda Galaxy. If not, don't worry, you can use any old image from your file system that you've got hanging around. It really doesn't matter at this point. It is just a demonstration, and Fedora is file agnostic. It will save any form of binary that you throw at it. So what we're going to do, we're already in the Andromeda Galaxy, hopefully. If not, take yourself back there if you need to type the URL in again, but you should have been left there by the previous operation. On the right-hand column this time, we're going to select binary from the type. And in the identifier, we're going to give it a file name, or it's still an identifier, but we're going to use the file name as the identifier. So we're going to put andromeda.jpg. In file, you can actually browse for the file on your file system. So if you click the browse button, you will be taken to a standard file upload type dialog where you can find the file on your local file system, whatever your operating system might look like. And once you return, it should be highlighted on the right-hand side as the file name that you've selected. And then we're going to hit the add button. So let's have a look and see what that looks like. So from type, well, sorry, just to confirm, we are in the Andromeda Galaxy underneath image collection. So over on the right-hand side, create new resource. We're going to select binary this time, which is the bottom selection for me. I think it should be for everyone. Identifier, we are going to call it Andromeda.jpg. Again, just going to undo the capitalization. So I'm going to choose file. And in my demo directory here, I have Andromeda.jpg. You can see that once I've selected it, it's actually given me a little thumbnail of it, which I didn't know it did. And it's given me the file name on the right hand side. So we know that's the file that's going to get uploaded. It's auto detected the MIME type here. This is something that the UI does that you don't get for free when you use the API. This is just a JavaScript function that adds in a little bit of usability for the user. And then if we hit add, you'll now see that we are down in the Andromeda.jpg binary. If we look at the URL in the URL bar, you'll see that we're actually in andromeda.jpg/FCR metadata. This is because if you actually requested the URL ending in the .jpg, you would actually get the binary file. So as an implementation note, in order to provide metadata for the binary, Fedora adds on a pseudo address underneath it. So the FCR metadata doesn't really exist per se, but it's a way that we use to display the metadata for a binary object. So if you're ever looking for the metadata for a binary object, know that you have to add on /FCR:metadata to the end of the URL from the actual binary file itself. But ultimately, in the UI, it looks just like any other resource. You've got the full identifier, first of all. You've got the created timestamp and the last modified timestamp, no children, and you've got some additional properties now. From the EBU core ontology namespace, we've got a file name, and we've got Andromeda.jpg as the value. We've got an EBU core has MIME type, and it has the MIME type of image/JPEG. And then in addition, we have a premise size here, which is the size in bytes. And you'll see this time that the RDF type is a Fedora repository binary. And in LDP terms, it's a non-RDF source. There are no other resources at this time. So it's back to the slides. Okay, so I mentioned about the FCR metadata already in the browser. So this is just confirming that's been already stated there. It says, yes, the FCR metadata part is an implementation detail, but the fact that the RDF that describes a binary has a URI and can be linked to is important. Okay, now we're going to modify or update the RDF for an object. So in your browsers, you're going to return up from the binary up to the Andromeda galaxy. You should be able to do this through the interface, but if not, in the address bar, just remove the Andromeda.jpg from the URL and the FCR metadata and get yourself back up to the Andromeda galaxy resource. And what we're going to do is we're going to add a doubling core property of title using the update properties box, which is highlighted in blue on the right-hand side here. You'll see that there's some sort of boilerplate text already for adding. And what we're going to do is we're going to insert something inside the insert curly brackets. You can see, oops, sorry. You can see here we're going to add open and close triangle brackets and a space, DC colon title and a space, and then Andromeda Galaxy in double quotes. So what this means is the open and close triangle brackets are shorthand for this RDF object that we are currently in. DC title is the Dublin core namespace, and title is the property of the Dublin core within the ontology. And then the value that we're going to assign to it is Andromeda Galaxy. And finally, we just hit the update button underneath the form. So let's go and have a look and see what that looks like. Okay, so first of all, we need to go up to the Andromeda Galaxy. We can use the crumb trail here to do that, which takes us directly there, or go back in the browser, or you can just modify your address in the browser window.
Dan, oh, nope, never mind. You got it there. Thank you. Continue.
All gets you to the same place. Okay, so what we're going to do is we're going to scroll down to the update properties text entry box here. And we're going to pass all of the definition, all the namespaces that are being defined. And on our way past, you might notice, where is it? We've got premise, test, memento, RDFS, WebAC, ACL, vCard, XSI, XMLS, RDF, Fedora, XML, EBU core, LDP, DC terms, IANA, XS, Fedora config, FOF, DC, and there we go, right at the bottom, DC. So this is basically just assigning the shorthand DC to this identifier. So that just allows us to write in shorthand later on within the insert brackets, open and close triangle brackets, DC, which is the shorthand I was just talking about, colon, title, and then a space, and then double quoted, Andromeda Galaxy with a typo. Correct that. Okay, so we've got open and close triangle brackets, which is talking about this resource. So we're going to edit this resource and not another one in the graph. DC for Dublin Core, which is a shorthand for this URL here, just to make it easier to type. Colon title, so we're going to add a title property, and Andromeda Galaxy is the value that we're going to add. So if we hit the update button, over here now, you can see that we've added an additional property, DC title, and the value is Andromeda Galaxy. Hopefully that worked for everyone. Let's go back to the slides. So you can see there in the slide, the DC title was added at the top. I think the properties are listed. I was going to say, yes, they are in alphabetical order, so of namespace. That's why it's popped to the top. So the next thing we're going to do is look at deleting resources. We're going to go to the binary. So this is the Andromeda JPEG resource that we added. And we're going to press the big red delete button on the right-hand side. We're then going to reload the page that we were left on, and we're going to see something new. So just a reminder, we're going to start with the binary. We're going to press the red button, and then we're going to refresh the page. Let's have a look and see what that looks like. Okay, so we are currently in the Andromeda Galaxy container. And you can see that what's happened here is where we used to see the identifier, the URI, it's been replaced with the DC title. This is a usability thing that the user interface does for us to make things easier to read. DC title is a very commonly used triple for a lot of people across all of their resources. And the DC title is often quite meaningful, being a title. So we decided to actually display it on the page in place of the identifier. The identifier is still there, and it's in the URL bar as well. So we don't feel that we're really replacing something so much. But we can see here in the Andromeda Galaxy, we want to go down to the child. So The Andromeda Galaxy is a container. We want to go down to the binary that we created earlier, which is listed under children, and it's also listed under LDP contains. I'm going to click on this one under children. So now we've gone back down to the binary. The binary displays the identifier up here because we haven't assigned a title to the binary itself, only to the container that lives above it. And then we're going to scroll down on the right-hand side until we get to the bottom and we get the delete resource button. We're going to hit delete. And we've been taken back up to the container. You'll note this because we've got the title here and not the actual binary. If we click on the children again, and refresh the page, you'll see that we've discovered a tombstone resource at image collection, Andromeda Galaxy, Andromeda.jpg, FCR metadata. And we've got a departed timestamp. So this is the time that that object was deleted. Go back to the slides. So we've discovered a tombstone resource at that location and the departed timestamp. Fedora creates timestamps at the original path slash FCR tombstone. In this case, it's image collection Andromeda Galaxy Andromeda.jpg slash FCR colon tombstone. And a tombstone is a marker that there was something there, but it's been deleted. And in order to put something new in the original location, you actually have to delete the tombstone as well first. Tombstones are kind of they're multifaceted, but one of the things they do is a belt and braces approach to not allow you to replace a resource unless you absolutely mean to. And even then, the object isn't deleted from OCFL, it's just versioned. But there is a concept of purging within OCFL if you do need to make sort of permanent deletions within the OCFL object as well. We're not going to cover that just now, though, but just wanted to let you know that that is possible. Okay, so versioning. We talked about the Memento protocol earlier. Um, Versions are created automatically or on demand. You can specifically create a version at any given time via the API. Um, so some of the terms I'm going to use now. A memento is a versioned body of the original resource, or you can think of this perhaps as a snapshot. A time gate is an endpoint supporting time-based queries for mementos. In this case, it's an HTTP URL. A time map is a list of mementos, so a list of available versions, if you like. And original resource refers to the actual resource that was versioned in the first place, or from the previous reversion. Okay, so with using your California map this time, which is the other binary file that I asked you to download earlier, we're going to create a binary resource in the image collection again. In the type field, we're going to select binary again. In the identifier, we're going to call it map. In this case, we're not giving it a .jpeg or anything at the moment. We're just creating the container above the map. So it's just going to be map in the same way that we did Andromeda Galaxy before. And then we're going to modify the resource. We're going to update the metadata the same way we did last time. We're going to add a DC title. In this case, the value is going to be map of California. So it's exactly the same as last time, except the contents of the title changes and the name of the resource changes. So let's go and do that first, and then we'll come back to the slides. So I'm going to use the back button to get back to here, and then navigate back to image collection from the crumb trail. And we're going to select basic container. We're going to call it map. Actually, no, sorry. wanted us to do a binary, didn't it? Let me just double check. No, we're going to do binary directly. Sorry, yeah, my mistake. So we are going to select binary from the type. We're going to call it map. We're going to choose our file, and we're going to add it. Once we've added it, we're going to come down to the update properties, scroll through all the prefixes until we get to the insert. Like last time, open and close triangle bracket, DC colon title, a space, and then map of California, I think it was. And we're going to update the resource by clicking the button at the end once we're happy. Okay. So back to the slides. Let's just double check we've done everything we were asked for. We've created a binary called map, and we've updated the map metadata to insert a DC title, map of California. So now we're going to have a look at the versions. We're going to view the version history first of all. Uh, Here we go. So on the right hand side, if we scroll down past update properties, you'll see that we've got two versions here and the timestamps that they were created. You can click through to see the different versions, and you'll see that we're looking at a timestamped version here now. This is a historic version and cannot be modified, but you can still download the content that was held within it. If we go back, we can look at the other version as well. Again, this is a historic version and cannot be modified, but you can download the content. Okay, so that's versioning in a nutshell. Transactions. So what we can do is we can bundle multiple changes into a single version using the transaction feature. I won't be able to demonstrate this to you in the browser because this is something that's only really doable using the HTTP verbs and the HTTP API. But what I've got here for you in the red boxes is examples of how you would perform those using curl on the command line. So curl, if you don't know it, is just a command line tool that, oh, Aaron,
Sorry, just me. I
got a
just want to
question.
grab this question from the community doc before we get away from it. Someone was asking why is it when we were looking at versions, why are there excuse me, why are there two previous versions for an image that was only uploaded once?
So this is because we modified the RDF by updating the RDF properties, adding the DC title for the map. We created a second version at that point, I believe. Okay. Oh, sorry, I've jumped slides, have I? Yeah. So the curl command is it's kind of like a web browser in command line terms. It can perform HTTP operations, but from the command line. So what it's going to do is using the username Fedora admin, username and password, it's going to perform a post operation to localhost 8080 FC repo rest, which is the top level of our Fedora repository, and then FCR colon TX endpoint. So this is how we open a new transaction. The response will give a location header, and that location header is something we take and we use in all subsequent requests. to perform all of those requests within the same transaction. So you can see on the second example here, we've got curl and then -h to set a header. So we're going to send a header with our future requests. We're going to set atomic ID to equal a location that we were given back by the previous request. And this time we're performing a put operation to create a new resource at fcrepo rest test 1234 using the same credentials as always. And you could perform lots more of those put operations as long as you can keep adding the same atomic ID location header using the same location that you were given the first time. As long as that location always matches, all of those transactions or all of those operations will happen within the same transaction. And then when you want to commit the transaction at the end, you actually curl the transaction location that you got back in the first place. So the same location that you've been using as the atomic ID header, you actually put to that direct URL, and that will commit the transaction. I hope that makes sense. Without seeing it live, it's a little bit harder to wrap your head around. I appreciate that. Okay, on to fixity. Over time, digital objects can become corrupt for a number of reasons. Either moving files around on disk, operating system errors, network outages, even various types of magnetic media or spinning disk storages can become corrupt over time for a number of physical reasons as well. So what fixity checks help us preserve our digital objects by verifying their integrity, checking that they still were the exact same bits that we put on disk in the first place. Fixity works as part of Fedora's preservation tooling to ensure the long-term stability of your resources. On ingest, Fedora can verify a user-provided digest against any against the calculated value. So what this means is that if you got a checksum already from from a workflow system, or you've taken a checksum as part of your ingest process, you can supply that digest to Fedora whilst you are ingesting the object, and it will check against the digest that you provided to make sure that its version matches the version that you were putting into Fedora in the first place. So we support algorithms of SHA-1, SHA-256, SHA-512, and MD5 at present. And you can always request that a new checksum is generated by Fedora and checked against the checksum that it has in storage within the OCFL object at any time. So by hitting a single endpoint, you can request that a check is performed on that object. So we're going to check the fixity of the California map. And we can see here a screenshot of a Fedora repository. And the fixity button is on the right-hand side in green. So what we're going to do is we're going to go to our image collection map FCR metadata and click on the fixity button. So let's go back to the browser. So home image collection map in the crumb trail is the quickest way to get there. We can see, let's just check our browser. So we are in FC repo rest image collection map, and then we're in the FCR metadata of the map, and we're going to hit fixity. And here we can see the premise has fixity, and also the fixity properties are highlighted for us beneath. The Fedora user interface also provides a simple search interface, which is also available via the HTTP endpoints as well, and has a bit more functionality via the API than it does through the UI. But certainly you can do a reasonable amount of querying for your objects in the user interface. This is what it looks like. So you can see we can select a field and an operator to apply to that field. Available fields currently are Fedora ID, the modified time, created time, the RDF types, content size, and MIME type. And so, for example, something like content size, if you see the operators over here, you can see that you've got less than or equal to, you've got greater than or equal to, exactly equals, and you could look for all your objects that are over a certain size in bytes. If you wanted to get a report on the particularly large objects in your repository, you could use the created time to see any objects that were ingested after a particular moment in time. You could pull individual objects back by their identifiers, searching for the Fedora ID, and the request to support wildcards as well. Some of the data types support wildcard requests, so that you can only put in a partial alphanumeric and then a wildcard to sort of fill in the remainder and get a result set back. I will do a very quick search, although results are minimal in our repository. So search is available from the top bar here next to home. And by default, it's performed a Fedora ID less than or equal to an empty search term. So it's effectively returned all results, but it's been limited to a page size of 10. So it's only returning the first 10 results. So you can see there we've got all of the resources that we've created. We've got the image collection, the Andromeda Galaxy, the map, and the map's metadata. And you can see it gives you some basic information. It gives you the RDF types that are applied to that object, give timestamp that it was created and last modified, and you can click through to actually get to the object in time. Okay, there's also a statistics endpoint which can be reached at fcr:/stats. You do need to turn on metrics collection in Fedora using the FC repo metrics enabled equals true property. This can be done at startup time or in your Docker compose, or you can add it into any shell startup scripts you've got. It also requires you to run Prometheus as a collector to aggregate metrics and Grafana to actually visualize those metrics. This is an example dashboard using the pre-provided outputs in JSON that Fedora is configured to give by default. So you can see a collection of post resource times, get resource times, database latency, JVM memory usage, and error rates as well. There's a few more OCFL session latency and object latencies, garbage collection rate from the JVM, and the garbage collection times. These are some of the things that you get for free by default. Yeah, that's it for the stats endpoint, really. That's something that you may want to have a look at and configure and play around with. I think there are possibly some other. Oh, another question, Aaron.
Oh, no, sorry, I didn't mean to cut you off. Go ahead.
No, I think I was going to say that I think there may be a couple of other statistical things that aren't graphed by these examples that you can get, but that's about it.
There was just a question from the doc, and I think I know the answer to this, but I'll leave it for you. Is it possible to search for tombstones? They were noticing that in the default search, it did not bring back the tombstone object.
I've never tried.
I don't think it's
I
an
don't
option.
think
I don't
so because you
think
have. I was wondering if you could do it with an RDF property, but there isn't an RDF
there is
properties
not.
for a tombstone. I don't think so. If someone wants to correct me there, please do in the chat.
Thank you.
Okay, I'm going to move on quickly because we are running out of time a little bit. Um, so taking you back to Aaron's slide from earlier, components of the ecosystem. On the right-hand side, encircled here in the bluey green circle, is the Camel Toolbox. Now, Camel Toolbox is a third-party application that's maintained by us. It sits on top of Fedora and listens to the messaging queues. And from the messaging queues, it takes the messages and puts them onto an Apache Camel workflow, which at the moment does three main things. It has examples of an indexer for a triple store, an indexer for a Solr repository, and it can forward those messages onto an HTTP service of your configuring to do whatever you want. It's provided more as an example of what you could do. It will stand as a basic indexer for all of those systems. You might find that it does everything you need to out of the box, but it's also just a sort of a use case and an example implementation that you might want to take further and develop yourself. So talking about those messages that Camel Toolbox uses, um, the Fedora repository can either um, put out a topic or a queue using Apache MQ, which is built into Fedora. If you just want messages that don't necessarily have to be read by anything, you might select a topic. Whereas if you absolutely need to make sure that those messages get read by a system, then you probably want to switch to using a queue. Topic is the default. Queues can be turned on in configuration. So we talked about external indexing of Solr. This could easily be modified to work with Elasticsearch as well, although the example in the Camel Toolbox is currently for Solr. Oh, I should add that the Solr indexer is quite configurable as well. You can specify your own Solr XSLT to transform your objects and create a Solr input document with any of the properties that you wish to index contained within it. So just going on to talk a little bit more about the Camel Toolbox. I'm going to skip through this because I've kind of talked enough about Fedora and the Camel Toolbox at the moment. I
And
think
there's a
most of that's
video
been.
in the slide deck that folks can watch after if they're
Yes,
interested.
there is. I think we'll probably skip over the video right now, do you, Aaron, think?
I think so. Yeah,
Yeah,
we can move ahead.
there's Danny. He's available. It's on YouTube as well on the FC Repo YouTube channel if you want to find it there. And the video is entitled Camel Toolbox for Fedora 6.0 if you're looking for it. Okay, migrations. So Fedora we've created tooling to support migration directly from Fedora 3 to Fedora 6 because we're very aware that a large percentage of our users are still on Fedora 3, although they are slowly coming across now because of the existence of the migration tooling. Uh, so there's the migration utils tool, which will take an output from your Fedora 3 data streams and objects and create you an OCFL file system on disk. It's a command line tool. We may get a chance to demonstrate it in a minute. It's basically a single line tool to run. Depending on the size of your repository, it can take seconds to weeks to run. But weeks would be for a repository with millions and millions of objects and totaling terabytes and terabytes of data. Uh, Once you've performed that migration, there's also a migration validator. This is explicitly designed for validating a Fedora 3 to 6 migration to check that everything migrated successfully. We also provide some documentation on remediating your data before migration. There's some templates and tools and best practices available in the doc that's linked here. And there's also a step-by-step guide for migrating to Fedora 6, which is available on the wiki at the link provided. So, as I mentioned, you can go direct from Fedora 3 to Fedora 6 via the migration utils tool. To go from 4 to 6, there's a little bit more involved in the pathway. You have to get to version 4.7.5 first, and then using the import export tool, you export that. It has to be version 0.3.0 of the export tool as well. But you export your 4.7.5 repository. And then using the FC repo upgrade utils, you perform an upgrade from 4.75 to 5.1.1. And then using the FC repo upgrade utils again, you generate OCFL from 5.1.1 to 6.0 OCFL. And then by standing up a Fedora 6 on top of that OCFL created, either by migration utils from 3 to 6 or through the 4 to, through 5 to 6 pathway, if you start up a brand new Fedora repository, pointed at an OCFL repository, it will index it the first time it sees it. And by the time the indexing is finished, you will have a fully stood up version of Fedora 6 on top of OCFL with your previous data. We have heard some users are preferring to take their export from Fedora 4 or 5 and perform a new ingest rather than using migration tooling. If you want to do any data tidy up work, this is probably the recommended path to go through because you're not going to get the chance to make modifications to your data along the way otherwise. Often you'll find that people want to do some data clear up and consolidate the number of models or number of collections that they've got in their data, maybe some new modeling or new namespaces added. So that might provide you the more full solution to ingest directly into Fedora 4 from an export or directly from your Fedora 4 repositories.
Okay,
Okay, I'm going to try and demonstrate the migration utils very briefly.
let's go for
Thankfully,
it.
there's a shell script which kind of wraps it all up neatly to perform this nice and quickly for us. Um, but the migration utils is it's a single command line, but it has a number of arguments which can be performed, uh, which can be given. But basically, you can tell it what type of source you've got, whether it's a legacy for Fedora 3 or a Kubra, because there were different backend systems over time. You can tell it to limit and only perform a certain number of resources if you're in testing and you just want to run over, say, the first 10 or 100 of your objects. It takes a target directory where it's going to put the exported objects. It needs to know where your Fedora 3 objects are and your Fedora 3 data streams. If you've used an export from Fedora, it needs to know where that is instead. There's also a resume function. It will pick up from the last migrated object. So it does create, it keeps an audit log as it goes through. And if for some reason it's stopped or it crashes or it comes to an object that it can't migrate, you can use the resume function to continue on past that point for the next time. Um, you can tell it to continue on error or crash out on error. Crash out on error is the default. Uh, It needs to know a username. Or, you can supply a username to associate with resources, and you can also give it a PID file, so a list of PIDs in a text file, so that it will only migrate those PIDs if you want to be selective about the objects that you migrate from Fedora 3. Um, you can change the Fedora 3 host name that's associated. So if your network infrastructure has changed over time since Fedora 3, or you want to create these URLs at a new location, this is the URI that will replace the info Fedora placeholder. You can tell it the algorithm that you're using for the checksums. You can tell it to enable metrics, so a bit like the Fedora repository metrics. You can also generate metrics which Prometheus can read after the migration has been, or in fact during the migration, I think you can read those migration metrics. And then here is an example run. I won't pause on this too long because I think we can actually do this in the terminal now. So let's jump over to the terminal. Okay, so feel free to follow along at home if you want. If you downloaded the migration example that was supplied, on decompressing it, you will find that these files live inside it. There's a directory called Brown, a couple of shell scripts, demo script, and reset demo. There's a validate. No, sorry, there's not a validate.sh. That is a file that I've added in, as is FC repo migration validator. Don't worry about those. I've added them in if we got a chance to demonstrate the validator. So if we have a quick look at the demo script, This is just a shell script that basically goes into the brown source directory and unzips it because it's zipped within there, comes back out, and then it runs the migration. So you can see here it's a Java minus jar to tell it to use the migration util 651 driver.jar. It's a legacy type export. It's telling us the data streams are held here, the objects are down here. The output is to go here into Brown Fedora home and a working directory, which is kind of just where it keeps an index and things as it's working through. This can be thrown away afterwards, is going to be down in Brown work. It's then going to run a Docker instance, open up port 8080 and 6161.6, which is the active MQ port, and 8181 for the Camel Toolbox, I think, in this instance, but we're not going to look at the Camel Toolbox. It's going to give the Docker container a name, and it's going to mount in the new Fedora home here that we've just created here. And what it should do, oh, it's also, we're providing the Fedora FC repo properties file to configure the Fedora instance and telling it where to find that properties file once it starts up. We're using FC repo 651-Tomcat 9, which is the most recent Docker Hub available version of FC repo. And then we can go to our browser. So I'm going to run this. It's going to run through in a single process. So, and it is quite fast because there's not a lot of data. But taking these data streams, these objects, it's migrating. It's now standing up Fedora. Fedora is starting up. It's indexing. It's indexed 97 objects successfully. If we go back to our browser, uh, so we want to have a look at localhost 8080 FC repo rest. Here is a Fedora instance up and running. We can see it's migrated, it's indexed. These are the test suite objects from the Brown data. You can see that it's migrated the rels ext objects, the rels int, the internal relations, the audits, the doubling core, the mods, all the data streams have come across. We can download that content. Everything that was migrated has come across into Fedora 6. As simple as that. And if you want to have a very quick look at the migration validator, again, this is a single Java command. We're pulling in FC repo migration validator 121, telling it again that the data type source is legacy. Again, we pointed at the data streams directory on disk. Again, we pointed at the objects directory on disk. We pointed at the newly created OCFL root directory, and we give it a directory for our results. So it's going to print us out some results. So running the validator, it's processing the objects, it generates a report. You can see that it's created some HTML and JSON directories, as well as a resume text file. I believe the validator can be resumed in the same way that the migration utils can be resumed. And quickly having a look in the browser, we can see that in the workshop migration example validation results directory, HTML, and there's an index.html file here. This is the index.html file for every object that we migrated and validated. We can click through. We see there were no failed validations, 59 objects passed, and you can see all the successful validations for all the different tests that were performed here. So that, in a very swift nutshell, is the migration validator and the migration utils tool to get you from Fedora 3 to Fedora 6.
Just like that. That's as simple as migrations are, right?
I mean, it is just a one-liner. It's the prep work that takes the time. Uh, okay. So we've looked at migrating a sample data set. We've looked at the migration validator. We've seen some of the validations there in the thing, but they basically it looks at the object metadata, a list of the data streams, the size of the data streams. You can check the checksums. That's optional because that can be an expensive task and take a lot of time. So you may want to skip that if you're looking for a faster result. We can return the object count and the number of versions. There's the example. We've already run that in the shell script. We talked about the different arguments, and it's as easy as that. Any questions?
Yeah, we do have time for questions. So again, you can put them in the Q&A doc. You can raise a hand in the chat, however you'd like. We'll pause a moment and let people think. If you think of a question after the fact, the community Q&A doc will stay open. So please feel free to go in there and just drop it in. If you leave your name and email address, we can reach out to you directly with an answer once we get it, if it's beyond the timeline today. Um, all right. I'm not seeing any more questions coming in. Please just feel free to interrupt me if you do have questions about anything that was covered here today. Questions may come up later. We're going to give you our email addresses. Obviously, you've probably seen mine, so don't hesitate to reach out to me. We'll get you directed in the right way. Thank you all for your participation today. Thank you all for making the time to come and join us. We are going to be sharing the recording once it's all processed and ready at the end. So you will have that to go back to. We are unfortunately going to have to take down the AWS instances once the workshop is over, for the sheer coordination and organization of keeping those up and running. But you can download Fedora locally. There's a Docker container that you can use, or you can just you can get it from GitHub. I don't know, Dan, if you want to drop the link in there to go and do that. All of the steps that we covered today are in the slides. All of the images and everything will remain on the wiki, so you can continue to go and do that. If you would like to try the migration sample yourself, you can also the example is on the wiki page. So, and the shell scripts that Dan used today are all in that package file on the wiki. So you can feel free to go there. But just to wrap up today, I just wanted to say thank you all for coming. The Fedora community really is the heart and soul of why we do this, how we're able to do this. You know, it's the contributions, the commitment, the advocacy from you all as users that allow us to continue on this work. We are always actively looking for new and interested parties looking to lean in to the community in different ways. Contributions of all forms are welcome, whether that be documentation writing, development efforts, even just letting us know what you're using and where you're using it. That helps us build our understanding of our broad community of users. Another way that you can kind of pledge your commitment to the kind of the sustainability of Fedora as a program is encouraging your institution or advocating at your institution for becoming a member or contributing to our funding campaign. Obviously, being open source, membership is the only source of income that we have as a program to continue on doing this work. So for Dan, myself, being able to have the infrastructure and the time and resources to be able to continue to improve the software. So, membership really can take any form. We have lots of options available. I'm more than happy to chat with anybody about that. Our funding campaign that is open currently is to achieve the items outlined on this community roadmap here. I know it's very small text, but I can share that with you. But we appreciate every single one of you as community members. So just thank you in advance for that. You want to flip over to the next, Dan? There's some different ways to get involved here. I'm going to share in the chat before everybody rolls out, or hopefully there's some people still sticking around. Slack is typically the best and fastest way if you have technical questions or support questions of any kind. Slack tends to be the fastest way to get a hold of any of us or the tech and committer teams. If you're not a member of our workspace already, there's a form there to request your invitation. Recommended channels would be obviously the general channel for general conversation, tech channel, migrations channel. You can get a hold of all of us there. We do also have a weekly tech meeting. So this is really an open invitation. I can't really stress this enough. You do not need to be a developer. You do not need to be well versed in Fedora to attend or come to these meetings. We have formatted the meetings in such a way that the beginning is always held for drop-ins or pop-up topics. So even if you just want to come and ask a general question, introduce yourself, let us know that you're a Fedora user, there is space at the beginning of each of those meetings for any users to come. And then you don't have to stick around for us as we go through tickets. So we would love to have you join us there, even just to listen. You don't need to participate. Anybody is welcome at that meeting. So every Thursday at 11 Eastern, the Zoom link never changes. It's right there for you to participate. We do have community mailing lists that you can use. If you go to the link there on the wiki, there's some different avenues for communicating, but I would encourage you to go to Slack first. But you can look through the archives. That's a great way to kind of get up to date on what's happening. Email us, obviously, that's the generic program email, or you can reach out to Dan or I individually. You can flip, Dan. More ways to get involved. I mentioned some non-developer avenues for getting involved in the community. We are currently in the process of reviewing and editing all of the Fedora documentation for Fedora 6. So you do not need to be a developer. You do not need to be deeply familiar with Fedora 6. We are editing for things like grammar, spelling, broken links, broken macros on our wiki, making sure that it all reads correctly. So we are meeting every other week right now to go through. We have a checklist. All you have to do is click URLs, read some stuff, check some boxes. Everybody's welcome to join those sessions, even if they're 1 hour right now, but if you can only come for 15 minutes, you're welcome to just drop in and pop out as you're able. I will give one more pitch here for registering your Fedora instance. So we do not know, obviously, all of the places that Fedora is being used around the world. And the most accurate way and the best way for us to help you as users is to understand where Fedora is being used. So the link to the registry is there. You do not have to fill out all of the information that is required. There's only a few mandatory fields. But in order for us to understand a more accurate view of where and how Fedora is being used, this registry is really one of our best tools. So I would encourage you to go and fill that out. There is a group of us that meets monthly to work on drafting, creating, generating content for the website. So there's the website content working group. We're always seeking new members. And then we do quite a bit of cross-community collaboration, right? Fedora being that kind of middle piece of software requires other pieces for a full stack solution. We actively work with our sister communities to make sure that all users have the support and tools that they need to successfully operate their infrastructures. So we are part of the Hyrax Fedora 6 working group that is based in the Samvera community. I regularly participate in the LACGLAM working groups. Sorry, I missed the last one to anybody that is here, but that is in the Islandora community. We also are closely connected, obviously, with the OCFL community. We are part of the OCFL Java Implementers Working Group, and we regularly get on the OCFL community calls. But this is our effort to continue to stay connected to all of the moving pieces that use Fedora. You can flip. Dan. And then this is just the last resources. So Fedora website, Fedora wiki, get Fedora, there's the GitHub, there's all the links to the migration tools that Dan used today, the Camel Toolbox. Please, if there's anything that I've missed there, feel free to jump in at any point. And I think that might be the last one. Yes, yes. We will hang for another 6 minutes. That's all we have for you today. So thank you all for joining us. We have appreciated you all being here and your interest in learning about Fedora.